So that is concentration. If we're talking about temperature, it's going to follow the same rules that concentrations do. What we have to figure out is which side our energy is on. For this reaction, our energy is on our reactant side, which means that it's an endothermic reaction. It needs energy for the reaction to occur in the forward direction. So, if I'm going to increase my temperature, energy is on my reactant side. So again, it's going to shift in the opposite direction. So we're going to have a shift to the right. When we shift to the right, that means we're creating more product. So our product concentration is going to increase, and our reactant concentration is going to decrease. Now, if we decrease temperature, again, acts just like concentrations. If I decrease temperature, that means that my reverse reaction is going to have to go faster. So this is going to be a shift to the left, which is going to cause us to decrease the amount of products that we made and increase the amount of reactant. So there is a little trick that I can show you in order to understand concentration and temperature. Now, I only want you to use this when we're talking about temperature and concentration, not pressure. I'll show you a different way to do pressure. We are going to pretend that we have a seesaw. So when you put more weight on a seesaw, it causes the seesaw to go down on that side. So let's deal with our products this time. If I increase the amount of products that I put into this reaction, it is going to cause the right side of our seesaw to go down. Now, in order to get back to equilibrium, we have to increase the amount of reactants. See that the seesaw's side is up, and we're going to have to decrease the amount of products. So this is going to be a shift to the left. You shift in the side that the seesaw is up, and it's going to be an increase in reactants and a decrease in products. Let's do the same thing if we decrease the amount of CO that we have. So when you decrease, that means that this side of the seesaw is lighter, so it's going to go up, which means that you're going to shift to the right. You shift towards the side that's up on the seesaw, and your concentration of CO is going to increase in order to get back to equilibrium, and your concentration of reactants is going to decrease to get back to equilibrium. Again, this will work for both concentration and temperature. The last thing that we want to talk about is pressure. Now, when I teach pressure, I want you to keep in mind Boyle's law. We learned about P1V1 is equal to P2V2. We knew that pressure and volume are inversely proportional. So if I increase pressure, my volume is going to decrease. If my volume is going to decrease, that means that there's less room for the gases that want to be in there. So in order to get back to equilibrium, we want to shift to the side that has a smaller number of moles of gas. And this is for when you decrease pressure. If you increase pressure, it's going to be opposite. This is for when you increase pressure. When you decrease pressure, you're going to have an increased volume, so you want to shift to the side with larger number of moles. So let's see how this works. What we have to do first is add up the total number of moles that we have on each side of the reaction. And again, I want you to realize that it's only of gases because pressure has the biggest effect on gases. So on this side, we're just going to completely forget about our solid. And we only have 1 mole of gas on our reactant side because we only have 1 carbon dioxide. If we look at our product side, we have gas and carbon monoxide, but now we have 2 moles of gas through its coefficients. So if I increase pressure, we are going to have a shift to the left, because that's the side with the smaller number of moles, and which in turn will increase reactant and decrease product. If I decrease pressure, I'm going to shift to the right, which will decrease reactant